So thank you all for turning up. This is InterSystems Iris Cloud Integrated ML presentation. This is something that was introduced in the keynote. Hi, Tom. The Integrated ML man himself. This was introduced yesterday, and some of you have seen demonstrations already, either in the kiosks or on the main display. And I'm here to talk to you a little bit more about it, introduce to you what it does, and see some of the benefits of using it. So, as I usually do, I found something that I liked when I was thinking about this topic. And it's a famous quote, and I hope the person himself will not turn up to tell me that he didn't say so. If we have data, let's look at data. If all we have are opinions, let's go with mine. So with that excuse, I'll introduce myself. I'm Kinshuk Rakshith. I work for John Payne here, sales engineering team in the UK, data platforms. And I promise you I have data eventually. So what are we going to look at today? So our agenda is an introduction to machine learning. And it really is no bigger than the word itself. It's very tiny. It's just an introduction. We're going to see how InterSystems Iris Cloud Integrated ML, it's a bit of a mouthful, actually addresses the needs of machine learning and helps you on your journey, and how we integrate that with any data science tooling that you might want to use to explore data and do your predictions, etc. Now, what are the benefits you'll receive? I think this is really meant for people who've got maybe some knowledge of SQL, not a lot. They can get started on their AI ML journey. You can quickly and easily deploy one of these machine learning environments in under a minute. It takes very little time to get started. And you can derive the intelligence from data that you already have. So you've got a data set. You probably think you have some trapped intelligence within it, but you didn't quite know where to get started. This is probably the way to get there. Okay, so what is machine learning? So effectively, if I can compare traditional programming and machine learning, in traditional programming, what you did was you provided the data and you developed the program or the algorithm, if you like, and you got an output out of it. And that was the case for a very long time. It still is the case for traditional programming that we spend most of our time doing. Machine learning, on the other hand, you have your data, you have an output that you've already found from previous either collection of data or from previous runs of the program itself. And now you are developing, if you like, the ability to work on the output and then develop a program so that you can give it further data, and then it can then work on future data and just give you that. So when would you use machine learning? It's a typical situation that you would use machine learning when any traditional programming technique or ability that you have doesn't solve the problem. There is no easy way to write a program that gives you the results that you want, and you already have the data, and you're sort of needing computers to help you get there. Okay, so what would you do? You'd start with a model, and what is this model? And a model is a program that can be executed, as it says. It's a file that's been trained to recognize certain types of patterns, and it's all about patterns. You train a model over a set of data, providing it an algorithm, and it can use it to reason over and learn from those data. So what kind of learning can you engage in? So the two types largely are supervised learning and unsupervised learning, and the difference between the two of them is in case of a supervised learning, you are providing it with labeled data. So you're saying, go and train yourself, but I'm telling you what the answers are in advance, and you kind of learn from the answers that I've given you already, and then when I give you further data, you provide me with that answer once again. In unsupervised learning, you don't have any such thing. You pretty much throw the whole data set at the machine learning process, and it effectively goes and tries to discover any hidden patterns in it. So you've got a lot of data. You might sort of do techniques like means clustering, etc., where it just breaks up data into different bits and tries to sort of find bits of data that are similar to each other, and then kind of find other bits which are not similar to anything that it's found before. So stuff like that. So that's unsupervised learning, and so you have both kinds. Now, in supervised learning, where you're actually providing with data, labeled data in advance, you have typical problems that you solve either with classification, as in you say, tell me whether it's true or false, tell me if this is going to happen or it's not going to happen. That's kind of a binary classification, so there's only two outcomes. And there are times when you have a multi-class sort of classification, so you say it's a cat or a dog or a giraffe or whatever it is, and we had some fun with that this morning. Right, and the other kind of supervised learning that you can do is via regression, which means you've got any number of values that a answer can have, and then you're just effectively it's a continuous set of values, and you don't have to say whether it's this or that. It could be anything in between. Okay, so that's effectively a very, very quick introduction. Now, what does InterSystems Iris Integrated ML do? It allows you to carry out supervised learning, and it allows you to do it purely with SQL syntax and very basic SQL syntax. So you don't need to be an expert at all in any way whatsoever, even with SQL. In a SQL environment, and it brings down the barrier to entry to a point where most of you shouldn't have any reservations about going and trying it out. It does not replace data scientists, as we say, and it rather is the beginning of the journey where you might want to discover some intelligence from the data that you already have, and then engage with the data scientist afterwards, or perhaps you already have a data scientist and working with them. This is kind of a flow chart. There are things that we do at the moment and we don't. Let me make that very clear. So we've got the ability to specify a machine learning provider, and we're going to look at that actually in the next slide. Perhaps the ordering of the slide should have been slightly different, but we have a bunch of machine learning providers who we've integrated InterSystems Iris with. There are providers like H2O, there's AutoML, there's DataRobot. You've heard these names before, but we'll talk about it a little bit more. For now, the default is H2O. So if I can just point and expect this to work, maybe not. So we're not going to look at this place where we actually specify an ML configuration at the moment. We're simply looking at having a provider already. We're going to give it a model. We're going to train the model. We're going to then carry out some kind of prediction on it. And we're going to also check what probability that the ML provider comes back with for the data that they've actually computed for us. Okay, so let's see what the 4 steps are in a sort of a simpler manner. So you create a model. That's the definition that you like for the machine learning file. You train the model. This is probably the most important step, where you let the machine learning provider go and work on the data that you've already got, and then go and discover any intelligence that it can find from it. And we will actually look at that in a moment. Validate model. So validation is a process where you're trying to find out how much confidence the machine learning provider has in the data that it trained with, in the model that it trained with. And it gives you some parameters, it gives you some values for you to get that confidence out of that trained model. And then, of course, you go and predict the model. So these are the 4 basic steps. The SQL commands that go with it are actually the same verbs. So you have the create model, train model, validate model. The ones that I was talking about just a little bit ago, the create ML configuration, set ML configuration, is where you can actually tell InterSystems, Iris Cloud, IntegratedML to set one of the particular providers that we've got as your provider of choice. So you might want to say, I want to use AutoML, or I want to use H2O. However, at the moment, the default is H2O, so we're working on that functionality, and you will have the ability to do that in a short course of time. We also have alter model, drop model, etc., which we will not be going into the demonstration of. And then we've got a couple of SQL functions. So these are additions, sort of extensions, that you would also use in your SQL syntax, and you would say predict a particular model, or giving the probability for that particular model for a particular field in that table, if you want to call it that. Right, so as I say, I probably got the ordering slightly mixed up. I should have got this slide earlier. So these are the providers that we've got. DataRobot is a subscription-based service. So if you already have a contract or an understanding with DataRobot, you can plug it in, and we can make TCP calls out of InterSystems Iris into DataRobot, whether it's on cloud or actually running on-prem. We also have the ability to handle PMML, which is a predictive model markup language, where you have got a particular file which specifies how your machine learning is going to, what machine learning functionality you want to implement, and we can work on that as well. So these are all pluggable machine learning engines, and at the moment, as I say, our default is H2O. Okay, so the interface is really clean, very simple, hopefully something that most of you are going for the first time will intuitively know what to do with. So you've got the login screen, and once you log in, you'll be able to create new deployments. So I'm just giving you 2 screenshots to look at the moment. And then you have the ability to import files. So you've got perhaps a data in a table somewhere. You've probably got it in a SQL, in a CSV file somewhere. You just want to import it, and you can do that very easily with the interface that you see. We're going to go and have a look at that, and then effectively you're just going to do the 4 things: create, train, validate, and predict. So one of the things that I wanted to use to demonstrate this ability to use integrated ML inside our InterSystems Iris cloud portal that we've got is an age-old problem, because this is, for astronomers at least, it's a very fundamental problem. When you look at a light source in the sky, and this feeds into other search for artificial intelligence, etc., you have to be able to tell by looking at a light source whether it's a star, it's a galaxy, or a quasar, because depending on what they are, the potential for finding other possibilities within them increases dramatically, or doesn't do that so much. So we effectively use their spectral characteristics, so their wavelengths, how they filter certain lights, and these are not just visible spectrum light, but this is electromagnetic radiation. And what we've done is gone and got a data set of 100,000 observations. This is a publicly available data set from Sloan Digital Sky Survey. I've given you a link to the place where you can get it yourself. And there are 17 columns in these within this data set. And it's got things like right ascension, declination, etc., which is just latitude and longitude projected outwards into the sky. And so on and so forth. And the data set actually has been downloaded from Kaggle, which is a very popular data science website. And then again, I've provided a link to that. And that's as much astronomy as I am allowed to sound knowledgeable about. So without delving into too much, let's go and see what we've got. So that's super. So this is our cloud portal. I've actually logged in already. There's a little value in me logging off and logging back in, but if I want to do that,
make sure you're still logged in.
that's probably a good bit of wisdom which I hadn't thought of myself. So that's my account, and then I've just enlarged the screen enough so you can see it from the back of the room. There we are. And as you might expect, I've actually got a deployment running there. That's what we call them. But purely to show you that it takes about 60 seconds to deploy one of these things, I'm going to go and do one for you. So we've got InterSystems Iris services listed over there, and the one that we are going to have to base IntegratedML upon is the Cloud SQL. So you can't do IntegratedML just by itself. You can fire up a Cloud SQL deployment. You have questions, sir?
Yeah, you took these, the data from the stars and you broke it into 17 columns.
Yes.
But for example, let's say you have something like an EKG waveform, and you want to be able to say, what disease does this guy have? So if you have, let's say, an EKG waveform and you want to predict what disease they have and you want to train it,
Yes.
I mean, do you need a data scientist to break this down into things, or can you just enter as one column the whole picture? How do you do that?
So if you're looking at EKG, you're looking at visual data, obviously. Yes. So this is supervised learning. So you will need to provide it with an image, which then says, yes, this is the condition that relates to this image. This condition relates to this image. So you will need to have that in your data set before you can start training the model.
So you can have the whole image as one column, and that will be the input?
So the image, effectively, the way it will get processed by any of these machine learning processes is it's actually going to look at probably the bitmap within the image, or some kind of a digitization of that image itself. And obviously that digitization translates to a visual representation. Again, if I might clarify, image classification isn't an area of expertise for me. So if I'm saying something that is patently wrong,
So I would just say, Aviel, that well, I think you're talking about. The EEG data would be not an image, but a waveform, right? Similar to like just a 1D image. And if you're having a classification of that kind of data, you're going to have to do it yourself to get it into integrated ML format. So that's a lot of pre-processing, not necessarily. And it's, so there's definitely a lot of work that you would have to do that. It's not really meant for that. And we don't do images either. So.
Thanks for clarifying that, Tom. So thank you. I've actually learned from your question. So Cloud SQL and Integrated ML, these are the two options that we're going to choose. We start with a small size, and that gives you 2 cores, 8 gigs of RAM, 50 gigs of storage space. Enable external connections. We want to connect to it from some tool of our choice eventually. Allow unencrypted connections if you want to. I'm just going to leave it unchecked for now. You can filter on IP addresses. You've got to specify a password that you're going to use to log into it with. I've already got one, so that just saves me typing. So I'm just going to keep using my stored password. I'm going to continue. We've got a couple of choices that you will have seen before if you've attended one of the other sessions. I'm going to stick with US East 1. And deployment name. I'm going to just call it GS22 Seattle 02 if you want. Okay. And make sure that you're happy with all of it. And we won't really be using this for very much. This is purely for the purpose of demonstrating how quick it is to start deploying one of these things. So while this is running, we'll come back to it in just a few seconds. We'll go into the one that I've already got over here. I'm sorry, can you hear me properly? I keep going in and out. I think the mic. Okay, super. I think it's me that I'm... okay, so integrated ML tools, SQL query tools, manage. I'm just purely going to look at importing of the data at the moment. Just to show you that when the deployment is actually ready, you will be able to see some things straight away. I'll talk about them in a little while. So let's see how easy it is to actually import data into this. This is obviously important, so it's protected by a password. So this is the password that we set earlier. SQL admin is the account that we are going to use. And so let's go and get some DDL statement where we are actually going to create a table inside the cloud integrated ML instance. We're just going to use Iris as the source, which is where I've generated the DDL from. I'm going to, for the purpose of demonstration, go into S3. And if I can just quickly remind myself, the bucket that I've got the data in is over there. Make sure I've clicked it correctly. Yeah, I have. So I'm just going to paste it in there. And the bucket is in US East 1, so that requires me to type that out. And I'm just going to say list files. I've obviously set the bucket policy in advance, so this particular S3 bucket already has been specified with the integrated ML instance that I'm connecting from. So I'm just going to use one over here, which isn't the one that we are actually looking to use for the purpose of the demonstration. This is purely to show you that we can import one of these things quite easily. And if I just go back one more time and I import something else, I'm going to say Iris. Actually, I'm going to go back one more space here. I'm going to say it's CSV data because I'm actually going to pick up the data. And once again, I'm going to go into this S3 bucket. And it just helps to have that quickly. Yeah, that's right. And US East 1. All right. And the list files. And I'm just going to get a... I might need to reduce the size of this. I'm just going to pick up one of these things. And effectively, this is a data set of house prices in Boston. I'm not actually going to use that for any other purpose, but to just demonstrate that it's quite easy to import a DDL. So, so what am I going to do? No, this is a CSV, so let me not confuse yourselves. Go back to import files one more time. And this time I'm going to say I'm actually picking up a DDL. And just the point is that the DDL is already inside inside our portal at the moment. Import files. Yes, and then I can just go and so it's telling me what it executed. It's a pretty straightforward create table statement. And I'm just going to say it done. It told me how fast it did it. And the next thing that I'm going to do is I'm going to pick up some CSV data, which also I've already picked up from S3. And this is the Boston train. The reason I've split it into two is that when you got a bunch of data, it's a good practice to separate them out. So you've got part of your data which you're going to actually train the model on, then you've got some of the data which you've saved up for you to get the confidence that the data with which you're validating it is not the same data with which you trained it. So which is why I had split this. So we've actually got the how should you say, the table already set up, field names, etc. If you wanted to go and check, you could always go and look at all the fields that are there in this particular CSV file. I'm going to specify that they are in the same order because they are, and I'm not going to skip anything after the header row. I have already said that there is a header row over there, right? So if I just import file, and that should just go and update 406 rows. So not a big data set, but that just demonstrates the fact that it's quite easy to set up a, create a table and import the data. And if I can go back to my deployments very quickly just now, you'll find that this one is already running, so the one that we just created. And for the purpose of the rest of the demonstration, I'm not going to go into that anymore. Just to show you, because I said we are going to use only encrypted connections, we need to get a self-signed certificate for us to connect to. And at the moment, we give you a self-signed certificate. In future, we'll be supporting the ability for you to bring your own certificates back, and we can use that as well. It tells you what the connection details are. This is the host on which it is running. It's running in AWS Cloud. This is a port that you would use if you want to connect to it from an external tool. In InterSystems Iris, namespace is a very important concept for us to partition where your data and your code, etc., run in. So this is all in the user namespace, and the username is given to you. The password is hidden, but it is the password that I set when I created the deployment. And you can go and change some of these things. You could also, which I learned yesterday, is this is the edit deployment size help. But what it does allow you to do is, if you wanted to go and get more data, you wanted more horsepower to run your machine learning on, you can go ahead and dynamically increase that to one of the larger sizes. And obviously, that comes with some kind of a cost implication one would expect. So I'm just going to cancel that for now, but just to show you that this is possible. Okay, right. Let's go and look at the actual integrated ML functionality that we've got. So I've already created a model, but the way you would create a model is, suppose you wanted to say, you wanted to create a model called Boston House Price Model. What table are you going to operate on? So that's the one that we just generated. And what do we predict? So I know for a fact that the field that I want to predict is called median value. And I can just create a model. And this doesn't do anything particularly demanding. It just simply creates a definition saying that this model's been created. And then you can go and train the model. So it already knows that I've created a model which is on the Boston house prices predicting median value. And then I can give it a name which I can call trained Boston house price predictor. Okay, and then I just say train model. Let's say, bear with me. I might have typed in some foreign characters in there. Trained house price predictor. Okay, so it's actually going ahead and doing that, and we'll come back to it in just a moment. It started it, and the time is actually time back in UK, so it knows that that's where I set up my account from. And I haven't bothered to change it after I came back over here. So we actually have to wait for it to finish, but in the meantime, if you wanted to see what's actually going on, you could keep going back to that table, and it's taken roughly about 15 seconds to train that. That's because it's only got 400 records in it. And you can go and look at the log file, etc. That's what it is. But I'm not going to dwell on that just now. what I want to do is I want to show you the fact that I've actually already got a trained model, and in this case, I'm going to simply go and validate it. Now, how would I know what I've got? I could go and look at show me trained models. So I've actually got the star classifier, which I talked about, and I did this a couple of days ago. This was trained using H2O, and it's called the trained star classifier. Okay, and let's go and validate it. So trained model to validate, I'm going to call it trained star classifier, table to validate from. I've actually got the data split into two. So data.star trainer's got 80,000 rows, and this one's got 20,000 rows. So I'm going to just validate with this one. I'm going to call it star validation 2. Excuse the typo. It shouldn't make any difference, but all right. So let's go and validate this. So it's actually running star validation 2. It will be done in just a little while. I can keep refreshing it. There you go. So it's actually done that. Now, if I want to go and get some confidence in this particular validation, I go and check on validation metrics. So it's, for those of you familiar with data science,
Try to stay forward toward the mark only because we turn here.
okay.
And the bottom is not important. And just
Super. All right, thank you so much. I will try to stick with that. So we've got the accuracy for each of these different values. So it says for null values, what is it? For F measure for galaxies, what is it? What is it for stars? Etc. These are the different values. I mean, we could have gone and actually explored the data set before we started, but I haven't actually gone through that. So it tells me, if I might just simply say by going through some of these, if you look at numbers in the region of 1 and 0.98, that's a fair amount of accuracy. It's a fair amount of confidence that that model has been trained well, etc. So I'm just going to hide that for a moment, and let's go and actually go and predict. So trained model to predict. So what do we have? So we're going to go and predict on the trained star classifier. Table containing input fields. So I trained it with a star trainer. I'm going to use the validator. So a number of rows to predict from the top. This is where I can actually generate SQL. There's more work to be done. So let's go and pick this up first. It's given me a kind of a template, a boilerplate if you like. Then when I go into SQL editor with this particular thing, I'm going to have to do a little bit of work. So let me actually face this way. It's much easier. So one of the things that you don't want over here is this ×1. This is something that you would use for a binary classification. Predict star classifier as prediction. Probability star classifier. This is where you actually have to give it a little bit more information. So what is the probability for? So let us say I want to check the probability that a particular record is a galaxy. And just because I can, I'm going to call it probability galaxy. All right, and from data.star validator, it's only going to give me the top 100, and if I execute that, hopefully, you will see that I've got the predicted value over here. This was the original value in the table, and it's giving me the probability. So the first one says, I predicted it's a galaxy, it was a galaxy, and my confidence or the accuracy was, the probability was 0.99. So it's pretty high. Now where it's got a star, it's telling you that I don't think that was a galaxy at all. So it's a pretty good data set, and it's been trained well.
What about the one that's greater than 1? Oh, I didn't see that. His mouse was over. Yeah. Got it.
Okay.
That makes more sense. Way more sense.
All right. There we go. So that's how integrated ML, how easy it is to use InterSystems Iris Cloud Integrated ML. Obviously, none of this is magic. It's data science. If it looks like it was a trick, it wasn't. It won't work without a good data set. And if you had data set which had inaccuracies in it and all the rest of the problems that you have with data wrangling that you all have to engage in for data science, you would find that the results would probably have fallen apart at some stage. So still the effort in cleaning up your data and making sure that it is something that you can work with doesn't go away. That still remains. But for a data set which is reasonably good, that's all very nice. So let me go back to the slideshow very quickly and see what else we've got. Okay. We did the demo. So what about data science tooling? Now, you already have the data inside InterSystems Iris. You might want to go and explore that further. Okay. So you might use something like Jupyter Notebook, which is a very popular data science tool for exploring the data. And the reason I say coming soon is because at the moment, what I'm going to show you is how I connect to the InterSystems Iris Cloud Integrated ML deployment from my Jupyter Lab on my laptop. But in future, you should have a box, or you will have a box foresee providing you that facility where you can actually deploy a Jupyter Notebook in the cloud itself. And so you've got the best of both worlds, at least most of the power that a data scientist is going to need to go and explore that data. And the advantage of showing you this running on my machine is that I can also demonstrate some of the, if you like, the drivers that we have. So I'm actually using DB API, which is a Python library to go and connect to InterSystems Iris. You could use JDBC if you're using .NET, etc. Those are available to you as well. Okay, so that's just a screenshot. I'm going to go and so I just want to display a couple of things. So the connection string, again, was something that we picked up from the deployment itself, which I would have pointed out to you. I can go back and show you that again if you wish. That download self-signed certificate, I did that earlier, and that's been saved in this particular location. It's been saved as a .pem, and the password is actually something that's been stored on my local machine. So if I just wanted to run that very quickly, just to make sure that that's happened, what I could just do, just to make sure that, give you confidence that the connection has been made, if I just go and say, we've actually got a cursor object, which is a Python object. I don't need that, I just need to did that work? Yeah, it did. It's given me a valid Python object. So we actually do have a connection. And so if I simply did, now I'm using pandas over here. And for those of you familiar with this tool, you'll see that the asterisk actually means that it's getting the data. In this case, because it's getting 80,000 rows, it's going to take just a few seconds, and that will complete in a very short amount of time. So I won't go through all of the things that I've run on this particular data set. It's got it actually, so that's fine. And so if I just go and run that again, it's given me the first few rows, and if I wanted to get some information on the just the main stats for this, it tells me there are 80,000 rows, etc. And I've done a lot of these things before, so I'm not going to go into all of that, but I think I'll take you right towards the end of this thing. And these are some correlations on the different fields that I've got, etc. I think I just passed a field of interest. Let me go down further on. Okay, I just wanted to show you this. So this is something that I've computed earlier and given me an accuracy of 0.984. And what I did earlier was I actually used some algorithms to remove outliers from this particular data. So if you remember the validation metrics that we looked at inside InterSystems Iris Cloud Integrated ML, you'll notice that those accuracy figures were pretty close. They were around the 0.98, etc. So what H2O as your machine learning provider has done underneath the hood is it's actually done some of these things completely unbeknownst to yourselves and gone and done as much of diligence as is possible with that data and then provided you with that output. So that's literally most of the content that we were going to talk about, and in the last couple of minutes I'm going to run through whatever's left, and then we'll have a few minutes for anything that you want to talk about yourselves. So what is the main takeaway from this? So getting started with AI or ML for people who've got very little training in this field has never been easier. We've really made it very simple. So these are value-added services which we want you to make use of. Obviously, none of this would be possible without the InterSystems Iris Cloud SQL service that we've announced. Integrated ML can offer you a very quick turnaround. So that goes without saying. And we're saying that with the connectivity that we offer you, you can get data for your data science right out of InterSystems Iris databases. Now, this is the last day, so I don't have anything that is related to this subject to recommend, but if you want to go back to learning.intersystems.com, you will be able to see the recordings of the previous sessions. I say with a wave of my hands because I think that's the place to go to. Okay, and we have announced early access programs on a number of occasions to yourselves. Officially, this will be Monday, the 27th of June, when InterSystems Iris Cloud SQL will be available to you. Cloud Integrated ML will follow just after that. But if you go and sign up, we will make sure that you are kept posted. So obviously, don't miss this opportunity. We are going to benefit from this just as much as you are, both from the point of view of finding out what you think about it and for yourselves to actually have the chance to try it out and see what value you can get out of it. User experience, etc., everything. We want to hear what you think. That's me. I've got a Twitter and a LinkedIn account if you want to connect in any way whatsoever. That's my email address. And I want to say thank you very much for being so patient through all of this time. So, what can I answer that you've got burning in the back of your minds?
Quick question on when you're actually doing the create model and train model process, how do you propagate out any particular influencers to the integrated component? Say, I want to train, but I want you to use this particular methodology, random forest or tree, or out of the box it's going to make random selections or appropriate smart selections, but how can I influence that process?
So with integrated ML in its current flavor, it is what it is at the moment. You have a default machine learning provider because this is a service that we are fine-tuning and polishing. You don't have in integrated ML any way to specify any further preferences, if you like. It is really a service for those who want to get value out of data very quickly with very little background knowledge of data science. So for those who want to use more and more data science tooling, etc., they would be looking at other features outside of integrated ML. This is a kind of get in there very quick, get some results very quickly, and not a lot of how shall we say, specifying your preferences at this stage.
Okay.
I was hoping you'd run the housing price one so I can find the best price on a house in a good community. So if you can run that sometime and give me the best price, and when I go buying a house there.
Absolutely. So the thing to be careful about is that that's a data set with 500 rows in it. So in principle, it demonstrates the fact that we can train a model, but in practice, you'll find that with such a small data set, you're probably going to get there's something called a variance and a bias in data science when you're exploring data. You'll find that it is slightly biased, when you only have such a small data set to train with. But you can get bigger data sets. It's just that particular one I used because it was very quick to load into.
Well, as long as it has Paul Revere's house on there, I'll go with it.
Okay, well, I'll try and see if I can find the data that you're specifically looking for. But thank you for asking, sir. Okay, well, thank you very much for being here today, and do enjoy the rest of the Global Summit.